Hi, welcome to The Tai Show, brought to you by Bafunde TV. My name is Lea Mokeira. The Tai Show unpacks the relationship between technology, education, and innovation. These three are interdependent and related. And so, to unpack them, we have to learn and understand the intersection between these three. We can look at this intersection through different lenses. And on today's show, we look at it from the lens of problem-based learning. Joining us is Dr. Tony Omoenza. Welcome.
Thank you.
Dr. Tony Omoenza is a senior lecturer at the University of Nairobi in the School of Computing and Informatics. He's done his PhD in Information Systems. He's the founder of the C4D Innovation Lab. And again, he's the founder of Nairobi Innovation Lab. I wouldn't finish talking about him, and so I'll allow him to tell us more about himself.
Thank you, Lea, for having me at the Bafunde Studios. It's such an honor to be here. And of course, the subject of technology, innovation, education, and looking at that intersection of those three elements is something that is of exciting to me and very inspiring. I've been in education space for a while, a couple of years now. I've been very active in innovation, incubating startups, thinking through the learning methods that enable creativity and innovation to be spurred. And with my background in computer science and information systems, I've been very much engaged in technology, consulting, designing, and creating solutions that are of a technological nature. And now having this conversation on problem-based learning equally is exciting to me because I've been involved in a number of projects on problem-based learning in partnership with other universities, both local, regional, and globally. And it's exciting to think about how we can make a contribution to transforming education through problem-based learning as an agent to innovation. So thanks very much for having me, and I look forward to sharing my experiences and insights.
You're welcome. Evidently, we have the best person around to lead us through this topic of problem-based learning. And to begin with, from the topic, an amateur will say problem-based learning is learning from a problem. But we'll get a better definition and a better understanding of what is exactly problem-based learning. So, Doc, what exactly is problem-based learning?
Yeah, thanks very much. You put it in a nice way. You know, like as a lay person, you will say it's about learning from a problem. But then I'll take it a little further, is that you're actually creating a solution from a problem, and in the process, you're learning. So the outcome of the whole process is learning. And learning will probably be viewed as development of the mind. But you start with the problem, and you take enough time to understand the problem. We actually say fall in love with the problem. So you diagnose the problem from as many perspectives as possible. So you truly understand it, and then you begin to think about a solution. So the creation of the solution is where learning happens, because you need different sets of skills and activities at the different stages of creating the solution to that problem. So in a way, probably rather than even call it problem-based learning, we may want to call it solution creation from a problem, in the process learning.
Okay.
Yeah.
Solution creation
from the problem,
and in the process you are learning.
Yes.
The normal setup, or the normal person, is used to being taught a specific thing and then maybe looking for a problem later to analyze it.
Yes.
So what's the major distinction between problem-based learning or solution and the normal education setup, the normal traditional way of learning?
Okay, so you know there are levels of learning, and that's why we say we have different types of examining learning and evaluating learning. So you're right that traditionally, you know, if students were going to a class, they will be taught certain set of principles, tactics, processes, guidelines, and so on and so forth, and then they will be examined to see if they mastered that substance. Now, they may be given a project to solve, or a problem to solve, hypothetical in nature, as a result of the assumption that they already have the foundation which they have been given in class. Now, that's typically traditional. But then when you say problem-based learning, especially in higher education level, the approach is to start with a problem. And it is not a hypothetical problem, but it's a real-life problem. And it has an owner I mean, it has people who are experiencing that problem or a challenge. And then you ask a group of students, you give a set of principles to a group of students on how to solve that problem without dictating how they solve it. So you will just give them guidance and say, for example, as a team, you need to have a plan. As a team, you need to immerse yourself to the problem and look at the personas of that problem. Who are the people? Talk to the real life people about the problem. And then you go through that whole process of saying, okay, now we think we've understood the problem. What might be a solution to this problem? Then you begin to ideate together. So as a mentor or a teacher, you're going to give them some principles to help them think through the problem, diagnose the problem, think through ideas of solution, how to ideate, think through how they might do data collection, how are they going to do the research, how are they going to analyze that data, think through how might they prototype a solution to that problem, how might they create and test that solution, and so on and so forth. Now, in the process, they will learn as they solve that particular problem. Okay? So there is a bit of a difference in that regard. And what I have observed is that by the time people finish a problem-based learning project, they have learned very many things.
Okay.
Yeah.
But then this brings a challenge. I'm thinking in a setup of 10 students or 10 people in a group, you've already given them a guideline on what they need to do, and so they need to come up with solutions. How well would you analyze that this person A or person B, got the guidelines well, applied them, or how would you grade that this one is getting the concept, this one is not getting the concept? Because they are now working in a group and the end result is brought out in a group. So how would you grade that this one is making progress, this one isn't?
Okay. So you actually addressed a very critical component of problem-based learning, how to ensure that you can succeed in problem-based learning. You've talked about assessing actual learning taking place.
Yeah.
And then secondly, how do you effectively and fairly evaluate the team as well as individuals?
Yeah.
Now, you see, there is a phrase that says, if you go alone, you go fast.
Yeah.
If we go together, we go farther.
True.
We may not go as fast, but we can go farther. Mm-hmm. So on the basis of that, concept, you try to make sure that the group will go together. That's rule number one.
Yeah.
We have to deliberately make the group go together.
Myself as a guide.
As a guide. You're going to have to make the team go together. So you will observe the team. You don't dictate what they do, but you kind of guide. And that's what mentors do or guides do, to make sure that the team is moving together. Now, they will have diverse opinions.
True.
Because in many cases, we create multidisciplinary teams. And they will have different perspectives. Some will be eager to make a solution. Some will spend a bit of time reflecting. Some will even face certain challenges along the way. But the whole point here is you will help the team to move together along the stages. Now, they will have seminars and workshops as they try to solve the problem, but they have to be at the same stage every time. Now, that is to ensure that collective learning is taking place. Now, in addition to that, you have asked the question around how we evaluate.
Yeah.
In a traditional system, you're going to teach, and at the end of a semester, you will examine. Everybody will just do the same exam.
Yes.
When we structure learning like that, it is at the convenience of the teacher. What I mean is, I want to teach you, and I want to give you the same exam, okay? Same exam.
Yes.
Then I'll mark it. If you write A, all of you got it right. If you write a B, then you got it wrong, and things like that. It's at the convenience of the teacher. Mm-hmm. In the problem-based learning, we're trying to put it more and more as a student-focused or centered approach. And so we conduct an evaluation in that regard. We have techniques. Number one, the team can self-evaluate.
Themselves?
Yes. So we can create a tool where you independently evaluate every member. Okay? And you try to be anonymous and as objective as possible. Mm-hmm. And we give it a certain percentage of the overall weighting, and that could be about 10%, so that we give you a chance to actually tell us what we couldn't see as a student. I may have not seen how you were working in the field together. Number two, you have a problem owner. So, we don't do hypothetical problems. We look for real life problems. So we must be having someone who gave us that problem. And we will ask that person to evaluate the team and the team members how they went about solving the problem. Mm-hmm. Because it's not a one time. The interaction is not just one time. It's continuous. So at the beginning, they will meet to discuss the problem. And then they will come and give you some ideas of how they think they might solve the problem. And then finally, they will come and tell you, oh, you know what? We've created some prototypes and would like to test them, and so on and so forth. So the problem owner will have an opportunity to evaluate. Third, you as a mentor who is hanging around with them and working with them, you are observing them. And so you can also do some kind of evaluation. So it's a mix of evaluations, which then we aggregate together and get a score.
So the mix of evaluation is what we'll say it's just and fair, because the student or the group member also acts in evaluating them. So no one will really slugger, because your partner must evaluate you.
Exactly. And you know, think about it this way. By the time the student come to make a presentation at the end of their project, you will not fake it. It is not about memorizing something. It's not that, oh, you know, I have read this book and I've truly understood the thing. Rather, we're evaluating the solution that you created, and no one had a predetermination of what the solution would look like. I didn't know. All I gave you was a problem. Which direction you go in creating the solution is not something we're controlling. So when you stand at the end of a group, you know, in an evaluation panel, and you present your solution, there is no way we can fake it. I can see that you went through the process. I can see that you came up with alternatives. I can see that you piloted, and you will provide evidence of all that. And in that way, there is proof you genuinely learned.
So we get different solutions from problem-based learning from different groups.
Absolutely. If I gave the same problem to 5 different groups, chances are that I'll get 5 different solutions.
And so the 5 different solutions, do we gauge them depending on the ones who provide the best solution or the ones who provide just a workable solution? Okay,
so there you go. You're actually trying to figure out, what are you measuring? We're not measuring the product. Of course, if you have a good product, that's good. We're measuring the process.
Okay.
That there was genuine effort in tackling the components of each stage of problem-based learning and arriving at some meaningful solution that you can defend. Now, there is not going to be any one right solution. As long as the solution that you're creating fits the problem in one way or another, remember, we are all different. I mean, it's in a natural process. Some of us are more vocal than others. Some are more articulate than others. Some are analytical than others. And they will present their perspectives in different ways, okay? So we're not, in the learner-centered approach, in the problem-based approach, the emphasis is not the correctness of the outcome, in as much as we want to see how well that solution fits the problem. Of course, if you went through the process very well, the outcome will fit the problem.
Okay. So you've worked with innovation and problem-based learning institutions, institutions that take up problem-based learning. So what are the examples, typical real-life examples of problem-based learning solutions that you've come up with or learning that you've done in that sector?
Okay, so over the last several years, we've worked with a number of universities on a few projects. So I will demonstrate or try to illustrate a few. We've worked with Aalto University in Finland, Makerere University in Uganda, and University of Dar es Salaam. And we've tackled a number of challenges. Now, each of these students normally organize themselves in groups that are multidisciplinary, and we tackle certain problems. Now, the most recent, we've done very many. Now, the most recent is where we have group of students partnering between University of Nairobi and Aalto University in Finland, and they are trying to solve the urban mobility challenges around transportation. And so we give the title, Decongesting Nairobi.
Oh, nice.
Now, if I gave a group of students decongesting Nairobi, and they are mature students, and they come from different disciplines, and they need to tackle that challenge, you can be sure, if you had 5 groups trying to solve the same problem, they can come up with different ways of solving that problem. So we have 2 groups. Now, some of them got persuaded that the problem of decongesting is because of poor manners in the way some people drive. Some were more interested in looking at, public transport. How might we improve the quality of public transport? It's by educating the matatu touts on how to be more courteous. I mean, just giving decent services to consumers. So, classic example, we did not determine how they are going to arrive, what they are going to try and solve, but at the end of the day, the 2 groups solved. Now, I can give very many other examples of challenges we've solved around aflatoxins, around maternal mortality, and so on and so forth.
You've heard about project-based learning.
Yes.
what is the major difference, or what's the distinction between project-based learning and problem-based learning?
Okay, interesting. This is my definition based on my little experiences of dealing with this kind of projects and challenges. I just differentiated them on the basis of those two terms. Now, problem-based learning, I say that we're going to start with the problem.
Yes.
We have no clue what the solution is going to be, and we're going to spend enough time thinking about the problem and looking at the various dimensions of that problem so that we genuinely understand the problem. And then we go through towards creating a solution. The solution is unknown and unpredetermined.
Yeah.
But when we do project-based learning, we tend to focus more on defining a project and then asking the team to create, to solve. Actually, they are actually creating the solution as we have defined it. So I might say, I'm going to give you a group of students a project to assemble a phone. So I've got a device here, and I break down it into parts. I give you a diagram, and I say, by the end of the semester, I want to give me this phone. You know, these are the parts, and I want you to produce for me this phone. I'll see that as a project, and I'll say this is project-based learning. The engineering is clear. The assembly is fairly clear. The aesthetics, the look and feel, they're fairly predetermined. But if I tell you, okay, two people in a rural setting are unable to communicate to each other because they don't have electricity, and it's during the month of July in Nairobi, and therefore there's not much sun, and therefore the solar system doesn't work, and they need to communicate. For some reason, they've been unable to communicate. Now find a way to get them to communicate. By the way, you might come and say communication was not the problem. In other words, I tell you that the problem is that these people are not able to communicate. Then I tell you, go and immerse yourself in those people and observe why are they not able to communicate. Now, when you immerse yourself, you can actually come back to me and say, oh, I want to change the problem. The problem is actually not that they are not able to communicate. It is something else. All right? So by immersing yourself into the problem, you're trying to figure out what really is the issue. That's step number one, and then you try to create. And you can tell that that is really different from when you're doing a project. Now, that doesn't mean that when you're doing problem-based learning, you will not create a plan towards creating a solution to that problem. Rather, you actually have a project plan to solve the problem.
You have a project plan to
solve the problem. Because you also can't just walk into the street and expect a solution from a problem. You have to have a plan. So there has to be a project plan, your own project plan, for solving that problem.
It seems to me that in project-based learning, you sort of already have a fixed solution you're working towards. Is that the case?
More or less.
While on problem-based learning, the solutions can end up being many because you're working on providing a solution that's not predetermined already.
More or less. Now, that's my definition. That's how I try to separate them.
That is what
Some
I'm
other
getting from
authors
you.
might have different perspectives and researchers, but that's how I try to separate them. And it's a bit debatable, but at least it helps me to organize my mind around how to solve these things.
So I'm thinking problem-based learning really has a lot of procedures. There is cost, there is creating a group, identifying plans and measures.
Yes.
How cost-effective is it to work with problem-based learning?
Okay, good question. I mean, it's a perspective that is very interesting to think about.
Or better put, also add what resources and dynamics do you need for problem-based learning to work?
Okay.
Yeah.
So yes, it is not a cheap thing. I mean, like when we say, like I said, I mean, if we organize students in a class and teach them something and then give them an exam and go away, that is at the convenience of the teacher. Everything is revolving around the teacher. But you know, these students are all unique and different in their own ways. And they pursue things, they understand things in different ways. So when we're doing the problem-based learning, we are trying to be as student-centered as possible. And that comes at a price because the students are different, their needs are going to be different, the way they will think about the problem is going to be very, very different and unique in own ways. But generally, this is what we try to put together. We have to get a real owner of a problem because that engagement is going to be very necessary. You don't create a problem that is hypothetical. I mean, you don't create a solution to a problem that is hypothetical. We try to create a solution to a real problem. Problem owner. We try to put a bit of attention in proper documentation of the problem. Okay. You see, that is a skill. Writing down a problem is a skill, which we are now imparting on the student.
Okay.
Now, Interrogation in order to truly understand that problem, engaging with the users, engaging with the customers, engaging with the partner, engagement is a skill, all right? Yeah. So we've got to equip the team when they go to the field that they will genuinely interrogate the problem and understand it. We need mentorship. Now, working as a team, the journey of a team means they will disagree. Remember, they're multidisciplinary.
Yes.
They will look at these things differently. They will have their own perspectives. There are those who want to work faster. There are those who feel we're taking too long on this matter, and so on and so forth. So mentorship and guiding them around the team dynamics is very crucial. You've got to explain, you've got to closely work with the team so that they capitalize on each other and they see each other's perspectives. That in itself is a skill.
Okay.
The willingness and the patience to listen to each other and to collaborate together on each of the phases is itself a skill.
True.
All right?
Yeah.
And then you're going to ask these guys to make a presentation. That in itself is a skill.
True.
You're going to ask guys to ideate. They have to come together and do divergent thinking about how they possibly might solve this. So that divergent thinking is a skill.
True.
Convergent thinking, data analysis. They've already collected some data from the field. They're going to analyze that. That's a skill. And then they begin to think about how they prototype the possible solution. That's a skill. They're going to negotiate with each other about, okay, we don't have enough money, so this prototype can't work unless we remove some elements. And they are going to negotiate about that. That's a skill. So it's a variety of skill. Now, you will need some resources, financial or otherwise, especially if you're going to do some field work, if you're going to do some ideation, if you're going to do some prototyping. And that has a price. But if you ask me, that price, monetarily, if you look at it, is absolutely worth it.
Problem-based learning. You pay a price, but there's value for that price. And evidently, we've seen that you learn teamwork, you learn different skills, and the mentor will guide you through. So the result or the solution you find is actually effective. Though you may not find an effective solution, you'd have gone through a very good process and learned. And the whole process of problem-based learning is to learn. So see you right after the break. Remember to turn to our social media handles. Our Twitter handle is @Bafunde, #enhancing learning. See you after the break. Hi, welcome back, and we are picking in tap from where we left it. We've learned that you'll get to learn very many skills from problem-based learning, but the question is, what age or what kind of person should engage in this problem-based learning kind of learning method? A pupil, a student, who exactly should engage in it? A small kid or only postgraduate, undergraduate? Doc, tell me.
Okay, so thanks. That's a very useful question. Surprisingly, anyone can participate in problem-based learning. You know, it's almost like saying, who can build a house? If you ask a 3-year-old child to build a house, they will probably build some kind of temporary structure using some toys and some small bits in there. So we say anyone can participate. It's just that the level of complexity will vary. Now, in our little experience, we find that there's a lot of value on problem-based learning at graduate school level. After the first degree, you find that students have mastered certain skills in their own disciplines. So you need that depth of understanding in different disciplines, and then you can try to put it all together into a team that is trying to solve a societal challenge. Now, what is interesting in that regard also is it depends on the kind of output that you desire to see through an output-based learning, problem-based learning approach. Because the whole emphasis is about learning, okay? Now, what you produce at the end depends on the complexity of the problem, as well as the capacity of the team to put things together towards a solution. So anyone can participate, but our experience has been that the more mature students are in their own disciplines, the better the experience and probably the better the solution that they can get to generate.
Okay. So anyone can participate.
Absolutely.
Besides age. Do you need
Absolutely.
any skill or any particular skill for you to be best suited or participate for problem-based learning?
So see, I mean, if I have a problem, we don't actually limit ourselves to certain domains of problems. We just look at problems in society as they are. So let's take an example. COVID-19 is a problem.
True.
And then I know we're going to do different kind of things in solving this problem. Okay, some people are going to try and get a vaccine, some people are going to try and promote social distancing, human behavior, and so on and so forth. So if I take a challenge like, I have just realized that people in a certain place, the transmission and people getting affected, this is really too high, then I tell you that's a challenge. Now, in the team, there will be maybe someone with biochemistry background, a computer scientist, an engineer, a communicationist, and maybe an anthropologist. 5 people.
Yes.
Now that problem is not for anyone.
It's for all of them.
It's for all of them. All right. They're gonna work together and come up with a solution. Now the communicationist will probably tell you is that the information, the way it has reached these people, is not appropriate. Maybe this information needs to be sent this way. The anthropologist will tell you, no, the behaviors of these people, the cultural issues, the way they see the world is very, very different. The engineer will tell you, no. It means we didn't give these guys the right devices. We need to create some kind of a device that can do this for them and circulate the whatever, and give them some signs that, hey, your social distance is, or you need a phone that tells you this is too close and so on and so forth. A computer scientist will probably, no, we need to program some data so that we can track who has got the disease much faster than and so on and so forth. So all these people are going to have different perspectives, and you're going to try and encourage them to work together towards a common solution. So there is nothing to do with what skills do you need. At least you need a preliminary knowledge of your subject matter, which you can build on, but now you need to enhance your collaboration, collective thinking, critical thinking, communication skills, negotiation skills, analytics, because you have to analyze data and analyze scenarios as much as possible. So you'll notice that once you have the baseline of your own specialities, then what you need to build on is more these 21st century soft skills that you will need to then make the team work. Now it's important also to note that, we go through the traditional system of education in silos and in various disciplines, which is all fine. So someone comes out as an anthropologist, but when they get out, they're going to work with a team of people from different disciplines. They start focusing on projects, they start focusing on problems. The more they can learn these additional skills, all right, the better they are likely to be out there when they adapt and interact with the rest of society in solving challenges.
So there's one thing that's clearly coming out, that any skill, you only need to be ready to work in a team. Use your collaborative skills, analytical thinking. More.
Yes. You're going to need your communication skills, because you're gonna have to engage the user and try to get as much information as possible about the problem. Don't conclude too soon. So you must interrogate. There has to be in-depth interviews, like really immersing yourself, alternative methods of data collection that you will immerse yourself to truly get what this problem is about. You're going to need to present, because you're going to convince someone that what you've probably created is meaningful, and you present, then you're going to creativity, you're going to divergently think about this thing before you convert. So it's a variety of skills that have to be developed over and above your core competencies. Now, because you cannot be also a core competent person in all the disciplines that are necessary, then it becomes necessary to start working with other people who have other disciplines.
True.
All right? And then now figure out, how do you, as an engineer, begin to genuinely understand a communicationist.
How then are we going to do this, given that the traditional setup is we are not used to real life problems, we're already used to reading, and when problems come, we'll sort them out later. So how are we going to do this? Or rather, how can you change the mindset of the teacher from a traditional conditioned method of teaching to a problem-based learning kind of teaching?
You know, that's a very good question. And in society, there is evolution. You know, the way education works, it's evolution. I have a very simple way of defining education. What is to educate is to develop the mind. That's my simple definition. And if we want to genuinely develop the mind, then we have to create the environment that makes learning and development of the mind to happen most effectively. Then we have to be conscious that every learner is different. Now, with that background, there may be a need to relearn and unlearn certain things as facilitators, as teachers. For example, in a traditional setting, a teacher is trying to impact knowledge to a student, but in a problem-based learning environment, the mentor is making the students to do the best they can do with themselves. Here is a problem. I will just make sure that you have your meetings on time. I'll just make sure that you have your communication, you're interacting within yourselves, and you are going to determine the solution. I will not determine the solution. I will not dictate it, but I'll ask you a few questions along the way to assess whether you are deeply reflecting about the problem, you are accommodating each other's perspectives, and so on and so forth. So the point I'm making here is that there is need to unlearn certain things and then learn certain skills in order to effectively facilitate problem-based learning.
We are almost coming to the end of this discussion, but my last question will be, why exactly does PBL work best in multidisciplinary setup? Why does it work best there?
Great. It's because challenges that we face in society are complex in nature and they are diverse in nature, and they need multiple skills in order to solve. You know, if you genuinely want to create a solution to a problem, then you're willing to look at it from different perspectives. And if you have the depth of skills from different backgrounds, they will help you to, first of all, comprehensively understand the problem. There is always an urge to create a solution after you think you've understood the problem.
True.
If you ask a typical programming student that, hey, I want you to create a software that can do that, the urge to immediately get onto a computer and start typing is very high. Because while you are telling the problem, they are thinking about the solution. And then they can want to actually create a solution. Oh, I learned how to do for loop, how to do this and that, and, data structure. If I do that, I'll create. So there's always an urge of wanting to go towards the solution before truly understanding the problem. And now that's the question. How do I know if you've truly understood the problem? There's no line somewhere I can say, now that's really truly understood the problem. Because sometimes what I think is the problem when I present it to you, it's not actually the problem. Okay. And I know very many examples of where we've presented challenges to students, and they would come back a couple of weeks later and say, by the way, we have proved that that's not the problem. This is the problem. Okay, so what I'm emphasizing here is the ability to look at the problem from different perspectives and begin to work on a journey of a solution increases the likelihood of getting an appropriate user-centered solution, okay?
Okay.
There can be many solutions, but you're looking for an appropriate user-centered and many times cost-effective solution to the problem. Now, for you to effectively understand the problem from different perspectives, you need a variety of skills, and that's why we look for multidisciplinary settings. When we're working on the solution, if you listen to an engineer explaining what they think the features of the solution should look like, that's likely to be different from an anthropologist. So if you look at anthropologists, they're more interested in the life, the behaviors, the reasons why people do certain things, and so on and so forth. An engineer may be interested in actually the technical parts that come together into this solution. But probably a marketer will tell you, hey, you know what? You can have the smartest engineering here, and you may have understood these people very well, but truly, no one likes the look of that thing. All right?
All right.
So then the engineer is able to say, oh, you're actually very right. I mean, you mean people don't like, and the way I've worked so hard to create this thing, oh yeah, they wouldn't like it, they don't care. And that is just the truth. So for us to get something that fits in the market and in the user's life, then we need these multidisciplinary skills.
Very well. I think very well, and I think problem-based learning should be adopted into our institutions, especially tertiary institutions, and intertwined with the normal learning sector. Or what is your opinion, just before we finish up?
In trying to get that...
In intermingling problem-based learning with the normal, traditional setup of learning.
It's definitely a journey. It's first of all that, you know, at policy level and at practitioner level, at faculty level, there has to be a deep appreciation of the need for problem-based learning. Once people appreciate the concepts and the principles and the philosophies behind problem-based learning, that's step one. Now, step two is to start asking, at departmental level, how do we start diffusing and implementing problem-based learning? You see, we can work in a non-multidisciplinary environment and still achieve problem-based learning. Okay? So we can have students from the same discipline, but they are solving a particular problem and they're going through the process of solving that problem. That is a step. So at departmental level, people begin to exercise problem-based learning in their individual courses. Okay? Of course, some skills have to be built among the faculty, and the awareness about how to go around, well thought out problem-based learning is important. Now, after that, we begin to think about how do we address this at the university administrative levels, and how can we begin to roll out programs like common courses. So there's nothing wrong in saying, for example, we will have a common course on design thinking, and in that design thinking program, we will have a problem-based approach, okay? So all students start to appreciate problem-based learning, okay? And then further on, we can begin to say, oh, in graduate school, we expect certain students to work together from different disciplines. Institutions are organized in colleges, and we can begin to have, college principals or head of colleges working towards multidisciplinary programs, okay, and say, oh, we're going to start a master's program where we're going to take 5 disciplines. I have seen scenarios where design, computer science and engineering, sometimes with communication, working together towards solutions. So if you have a design and you have an engineer and then you have a computer scientist, the likelihood that they can create something tangible that then solves a particular problem is very high. And we are now having universities that are actually running multidisciplinary programs. So it's a process. Different institutions are likely to be at different levels, but there is always, fast movers who have already implemented some of these programs, and those who are beginning. There's a pathway to getting there.
Okay. You need a learner-based solution, or rather learner-based way of learning, adopt PBL. You need to get appropriate solutions that have gotten concept from each and every person, solutions that can actually work, adopt this kind of system. And so thank you very much, Doc, for joining us. We're very grateful, and I'm sure people have learned a lot on PBL. So thank you very much, and thank you viewer, and see you on our next show as we learn more on other things that can help us understand the interrelationship between technology, education, and innovation. See you.
Thank you.